If you want to increase the value of your token, you have to make it more useful. For example, by providing a Flashloan feature so that traders can easily do arbitrage and liquidations. The idea is to start from a standard ERC20 token, add a few functions in Solidity, and have a token with a built-in Flashloan, also called a Flash Mintable token. If you don't know me, I'm Julien, and on EatTheBlocks, I teach blockchain development. This is how it works. So first you have the trader that is going to deploy a borrower smart contract. Once this smart contract is deployed, the trader is going to call a function on this smart contract. That's how we trigger the whole process. Then the borrower smart contract is going to borrow some tokens from the token smart contract. Because a token has a total control over its own token, it can mint as many tokens as necessary. This is different from a liquidity pool that can only lend as many tokens as it has. In the case of a flash loan provided by a token, it's going to mint the number of tokens that you are asking to borrow. So then it's going to lend this token to the borrower. The borrower is going to use these tokens to make a profit. So it can be arbitrage, can be a liquidation. And after these operations, the borrower smart contract is supposed to make a profit. After that, the borrower smart contract doesn't need to transfer its token to the token smart contract because the token smart contract can do whatever it wants with anybody token, including burning this token. So once the borrower has finished to do what it needs with the money that was lent, the token smart contract is going to burn these tokens, and then the borrower is left with the profit and send back this profit to the trader. Alright, so time to walk through the code of our token Flashloan. So this is the code of the project. In the GitHub repo of EatTheBlocks, this is a standard truffle project. So first I'm going to show you the dependencies that I've installed. I've installed OpenZeppelin contracts for the ERC20 implementation and OpenZeppelin test helpers for our test. So we go to the contracts folder and we're going to start with the goodborrower.sol. That's the contract that's going to borrow the Flashloan. So we have two imports, so the import of our token and also we import the interface of our borrower. So we need to inherit from this interface and implement the two functions start Flashloan and on execute Flashloan. So when we start the process, we are going to call start Flashloan and we're going to give as argument the address of the token that we want to borrow, as well as the amount that we want to borrow. Then we specify that this is an external function and the override keyword is because we implement a function defined in an interface. So in 3T 0.8 you have to use this keyword in this case. And what we do inside is very simple. We just create a pointer to our token and we call the function execute Flashloan with the amount that we want to borrow. So then in the execution, it's going to be continue by token.sol here. So we import the implementation of ERC20 of OpenZeppelin as well as the borrower interface. Here we inherit from the ERC20 implementation. So that's how we get all the functionality of ERC very simply. Here in the constructor, we call the constructor of ERC20. We give a name to our token as well as the ticker. And if you want to mint some token to the admin, you could do this here between the curly braces. You can customize this. And here, the part that is the most important is the function execute Flashloan. So it's going to be called by the borrower. As argument, we pass in the amount that we want to borrow. And we're going to call underscore mint that is provided by ERC20 from OpenZeppelin. The first argument is the address of the borrower. So that's the borrower smart contract. And then the amount that we want to mint. And so this function is going to create this token and send them to msg.sender. After, we're going to call a function on our borrower smart contract. So we here instantiate a pointer to this smart contract. And we call on execute Flashloan. And we pass two arguments, the address of the token and the amount that we borrow. So after we come back to good borrower for the execution, And so this function is executed. We pass it the two argument, token and amount. And after, it's up to you to use the money of the Flashloan. So you can do arbitrage, you can do liquidation, but you have to make sure that at the end you have enough token in order to reimburse the Flashloan, because otherwise the transaction is going to fail. And so when you finish to call this function, so we go back to token.sol, and here we continue the execution, and after we are going to burn the token that we minted before. Underscore burn, this is also provided by ERC20 of OpenZeppelin, and we have the same argument as for the mint. So we pass it the address of the senders, that's the borrower, and the amount. And at the end, that means that we created as many tokens as we destroy after, so the total supply should be unchanged. So that's for a good borrower, but I've also implemented a bad borrower to show you how it can fail. So it's almost the same thing as the good borrower, except that in unexecute Flashloan, we are going to send all the tokens that we borrow to a random address. And basically what I wanted to do is to simulate what happened if we don't have enough token to reimburse the Flashloan. So here we have our pointer to the token, and then we call the transfer function with some random address that I generated, and we send everything. And so that means that when the burn function of the token will be called, it will fail because we don't have enough token to burn. Okay, so that's it for the Solidity code. So after, I've also wrote some tests. So in the test folder, you go in token.js, and so here I've imported the contract artifact for the token good borrower, bad borrower. I've also imported a function called expect revert that comes in OpenZeppelin test helper that allows to test for error. After, I define a contract block, and we have two tests, a test for the good borrower and a test for the bad borrower. So let's start with the good borrower. So first we deploy the token, then we deploy the good borrower, then we get a total supply before the Flashloan, then we call the function start Flashloan on the borrower, and we pass the address of the token, and for the amount we put 1000 token. So this is completely arbitrary. You can put any amount you want here, just we need something for the test. And after, the Flashloan is supposed to have been successful, and we get the total supply after, and we are going to assert that the supply before is equal to the supply after. Otherwise, it means there is a problem in the logic of our Flashloan. So that's for the good borrower, and for the bad borrower, we have another test. So we deploy the token and the bad borrower, and after, we are going to expect a fair transaction. So you're going to test this with expect revert like this. And here we call start Flashloan on the bad borrower, and we expect a failure with this error message, burn amount exceed balance. And now I'm going to run the test. So I've already downloaded the repo of EatTheBlocks. I've installed all the dependency with npm install. And to run the test, you just do truffle test, and normally everything should pass. We wait a few seconds, it's going to compile everything. Then it's going to run the test. So the first test, the good borrower and the bad borrower, and the two tests are passing. Great. What I show you in this video is just one way to implement a Flashloan feature in your token, but you can customize the code. For example, you can add a fee to the system so that borrowers will pay a fee for each Flashloan, and you, as the admin of the token, you will make money. You can keep these fees for yourself or redistribute them to the holders of the token. Another thing I haven't mentioned is that there are some risks when you provide a Flashloan. Some people use Flashloans for legitimate uses like arbitrage or liquidations, but be aware that it can also be used for hacks. In any case, Flashloans are fascinating, and if you want to know more about them, check out this series on my channel. I will see you there.